All right, I think we're finally down to our last video here. We're working on the Unit 1 review for Algebra 1, and we're at 21. Word problems. Let's go word problems. So let's see, we have Megan deposited $1,625 in her savings account. Each month, M, she withdraws $45 for spending money. Write an equation that best describes B, the balance left in her account, in terms of M. All right, so her balance, let's see, she deposited $1,625, so that's like the starting amount. So her balance is $1,625, but she's withdrawing $45 each month. So how would I write that? I'm withdrawing, that's going to be a subtraction. You're going to be your balance is going to be going down, and you're going to want to put here 45M. So basically, if M were 1, at the end of 1 month, she would have 1625 minus 45 times 1, or just minus 45. And after 2 months, since she's now drawn or withdrawn $45 2 times, it would be 625 minus 45 times 2. So it's really important that you have the M there. And it's also important to know what each of your variables represent. So we know M is for month. $45 is the amount getting withdrawn each month. And again, B is for balance, or what's left in the account. And so that's our equation, 1625 minus 45M. On number 22, it says Hannah has a job at Best Buy. She earns a base salary of $500 each week plus $8 for each computer she sells. So write an equation that best describes Y. So Y is her weekly income after X, the number of computers she sells. The wording seems a little bit odd there, but all they're saying is there's X computers being sold. Okay, so her salary, which we're calling Y, well, and this is her weekly salary, right? Weekly income or weekly salary. It's going to be the $500 that she earns per week, plus she's going to get $8 for each computer she sells. So it's very similar to the one we did up in 21. Instead of subtracting to what we started with, we're actually going to be adding. So she's getting $500 plus $8 per computer, where X is the number of computers. So, for example, if she sold 10, if X were 10, then she would earn for that week $500 plus 8 times 10. So that would be $580. So the more computers she sells, the more she's going to make. And so you do need the X there. Sometimes people will just put plus 8. So your equation is Y is equal to 500 plus 8X. All right, we've got 2 more to go here. All right, on number 23, it says Sabrina's family is going on vacation. They can spend $300 per day plus $1,300 for plane tickets. If they have at most $5,100 to spend, what is the maximum number of whole days that they can stay on vacation? All right, well, the amount they spend needs to be less than or equal to $5,100. And how much are they spending? Well, they're spending $300 per day plus $1,300 for their plane tickets. So basically, $300 per day. Let's see. So we're going to have to make up a variable for day. Why don't we say D equals the number of days. So we're basically finding out how many whole number days can they stay on vacation. So they're paying or spending $300 per day. So that would be written as 300 times D, plus their cost for plane tickets, which is $1,300, and they need that to be less than $5,100. And so let's go ahead and solve this inequality here to find out how many days they can be on this vacation. So the first thing we're going to want to do to get D by itself here is subtract 1,300 from both sides. And let's see, when we do that, I'm going to go ahead and write the work over here. We're going to end up with 300D less than or equal 5,100 minus 1,300, which is 3,800. And so now, trying to get D by itself, I'm going to have to divide by 300. And so when you do that, you should get D is less than or equal to, it comes out to about 12.67. So they can't quite stay 13 days. It would need to be 12. That's because we need full days here. And so your answer here is going to be C. All right, number 24, it says, which equation has a solution less than 0? Well, let's see, if we added 2.5 to both sides here, that's what we would do to solve this, we're definitely going to be positive. So that's not less than 0. If we divided G by -3 on both sides, we'd get T is equal to +3, so that's not less than 0. If we subtract 14 on both sides here, we end up getting 5x is equal to -20. Divide by 5, and you get x is -4. And so we seem to have a winner here. Now, just as a check, you might want to make sure that last one is also positive. You subtract 2 on both sides, and you get n equals 1. And so, indeed, H is the only one that has a solution less than 0. All right, and that's it for this video.